This is the final lesson in Unit 6, so that means that a test is on the horizon. Make sure you look for the review sheet and plan ahead. Hi class, welcome to Lesson 42 of Unit 6. In this lesson, we are going to answer the question, how do balanced chemical reactions help solve mole problems? The objectives today are to explain the concept of stoichiometry as it pertains to chemical reactions and use balanced chemical equations to derive stoichiometric factors relating amounts of reactants and products. Make sure that you are following along with your notes and you have your scientific calculator with you so that you can solve problems as we go along. Today we are going to look at stoichiometric relationships. So the first thing we need to answer is, what is stoichiometry? Stoichiometry is a way to predict the amount of a substance needed in a chemical reaction. Now, it is important that we're able to predict the amount because we are not always given the perfect amount as displayed in the coefficients of the balanced reaction. The thing to notice is that all of the relationships we are going to study are based on a balanced chemical equation. In this equation for the synthesis of water, you will see that you will need 2 moles of hydrogen and 1 mole of oxygen to produce 2 moles of water. But how much hydrogen would you need if you wanted to produce 6 moles of water? So the coefficients in the reaction give us the ratio of moles or amount of each substance we need. So in this case, you can see that normally in a balanced equation, we have 2 hydrogen that produce 2 waters. But if we want to have 6 waters, we're going to need to scale up the amount of hydrogens. So we're going to need to have 6 hydrogens. One way some people figure out the missing amount is by balancing the equation with a given coefficient, in this case, the 6. So here we can see during the synthesis of iron 3 oxide, we have the mole ratio where 4 moles of iron and 3 moles of oxygen are needed to produce 2 moles of iron oxide. So again, you can see that every 4 moles of iron makes 2 moles of rust. But what if we had twice the amount of iron? Then we could make twice the amount of rust. So we can adjust the ratio from 4 to 3 to 2 to 8 to 6 to 4. Although for some, adjusting the ratio can be quite easy, there are 2 major steps that we should take to make sure we can easily adjust the ratios. The first thing you want to do is to determine the number of moles given and the unknown quantity and underline those in the balanced chemical equation. Finally, we'll apply our mole ratio and cross-multiply. Make sure you write down these 2 very important steps. Now we're going to try and solve this problem. Here we have a combustion reaction where we are burning propane in the presence of oxygen to produce carbon dioxide and water. Let's do this together. So as we begin to read the question, we see that we begin with 12 moles of propane. So we find propane in our equation and we underline it. And we now know that we have 12 moles. So I'm just going to put 12 underneath. Now we know that if it reacts completely, how many water are formed. So we are going to find the water and underline it. And since we're looking for the amount of water, we're going to call it X. So now we can set up proportions to help us solve this equation. So the number of moles is represented by the coefficient. The coefficient in front of our propane is 1. And we'll set that equal to the coefficient for water, which we can see as 4 over X. Once you get your fractions set up, it's a simple cross multiply and solve. So in this case, we will have 48 moles of water. Let's try this next question together. Do you have your calculator? Make sure that you are following along. In this question, we are given 2.5 moles of nitrogen. So we're going to underline nitrogen in the equation and write the given value 2.5 below. And the question asks, if 2.5 moles of nitrogen reacts completely, how many moles of ammonia are formed? So we're going to find ammonia here. And since we're looking for the number of ammonia, we're going to call it X. This sets up our fractions. So remember, the coefficients help set up the fraction. So for the ammonia, the coefficient is a 2, and we have an X in the question. For the nitrogen, there's no coefficient given, but instead, the coefficient of 1 is understood. When we set up our math, now we can cross multiply and solve. X is equal to 5 moles. Now we will work through one last example together. Again, make sure you are following along because at the end of this video, you're going to have to answer Google Classroom questions on your own. In this question, we are given the equation for the synthesis of aluminum oxide. In this question, it asks if you had only 1.8 moles of aluminum. So here we are given 1.8 moles of aluminum. If I underline the species in my equation, the aluminum, and I'll write the number 1.8 below. How much product is produced? So product, we have to figure out which species is the product. Remember, in all chemical reactions, the items that go before the arrow are put in and are called reactants. So here, oxygen and aluminum are reactants, and the item that comes after the arrow is called the product. So here, aluminum oxide is our product. So we want to know how much we can make, so we underline it and put in X. This sets up my fractions, so I'm going to write my fractions below. For aluminum, my fraction is 4 over 1.8. While for aluminum oxide, my fraction is 2 over X. So when we approach this with cross multiplication, we'll have that 4X equals 3.6. And then we'll divide both sides by 4. And we'll have that X equals 0.8 moles. This concludes lesson number 42. Make sure you've taken good notes, you complete your homework, and you bring any questions you have in class. Again, this is the final lesson in Unit 6, meaning there will be a unit test very soon. See you in class!